Hi, welcome to my video on the absolute value of a complex number. Recall, the absolute value of any real number is the positive distance from zero on the number line. The symbol for absolute value is the two strokes. Find each. Absolute value of 2 is 2. Notice on the number line, 2 is right here. So the distance is from there to there. The distance is from 0 to 2 is 2. And the absolute value of a negative 3 is positive. So from 0 over to negative 3, right here, that distance is 3. So the absolute value is the distance from 0 on the number line. What about the distance of a point, 3, 4, from the origin? So if we take the origin 0, 0, this is the x, and this is the y, and these are 1, 2, these are 5s, 5, negative 5, negative 5. So the point x is 3, y is 4, x is 3, y is 4. That's the point right there. So that's the point 3, 4. So what's the distance of this point from the origin? Well, if you draw a line from the origin to the point 3, 4, and you set up a right triangle perpendicular to the x-axis, then this distance is the value of y, which is 4. This distance from 0 to right here is 3, and that means that c squared is a squared plus b squared. C squared, a could be the x squared plus y squared, because the x. So, or I could call the distance, c is the distance d. So I call the distance, x is 3, y is 4. So that's 9 plus 16. So d squared is 25. So d is the square root of 25, which is 5. So the length of the segment from the origin to this point is 5 units. 5. Without a graph, the distance can be found by using d equals the square root of x squared plus y squared, which is the same as what I did here. Notice the distance squared, and if I do the square root, I get the square root, d squared equals x squared plus y squared. D equals the square root of x squared plus y squared, and the distance is positive. So if I did that, and I want to find the distance, the square root of x is 3, y is 4, that's the square root of 9 plus 16, that's the square root of 25, which is 5. So I could do it with the Pythagorean like I did here, or I could do it with this formula. And to do another example, find the distance of the point 5, negative 12 from the origin. Well, x is 5, y is negative 12, so d equals the square root of x squared plus y squared. So x is 5, y is negative 12, and we square 5. 5 times 5 is 25. We square negative 12. Negative 12 times negative 12 is 144. And that adds up to 169. And the square root of 169 is 13. So if you drew a graph, then this point is 13 units from the origin, 0, 0. Distance. Notice the formula. D equals the square root of x squared plus y squared. Find the absolute value of a negative 3, negative 4. Well, if you negative 3 is right there on the x, and the negative 4 on the y is right there. So the absolute value, which is written as negative 3, negative 4. Absolute value is distance. So the distance, you can either set up the point to do this if you want, like that, and go negative 3, negative 4 with a right angle, and use your Pythagorean, or you can go d equals the square root of x squared plus y squared. And the faster way is to do it with the formula. Again, you could do it with Pythagorean. C squared is a squared plus b squared. But if you do it with the formula, it's much quicker. Negative 3 squared is 9. Negative 4 squared is 16. 9 and 16 gives you 25, and the square root of 25 is 5. So the length of this segment is 5, using this formula. What about the distance or absolute value of a complex number, a plus bi? Well, let's look at the graph, and let's look at another formula. What about the point 2i? Well, if that's the reals, and that's the imaginary, the point 2i, this is imaginary, the point 2i is right there. So that point, the distance means the absolute value. So the absolute value of that point is 2. Notice we do not include the I. The distance is 2. The I is not included when we do distance, so the distance is 2. If we have the point 3, or 3 plus 4i, again, that's the reals, that's the imaginaries, and again, this is 5s, this is 5i, and this is negative 5, and this is negative 5i. So we have reals and imaginaries, so 3 on the real, and 4i on the imaginary, so there's the 3 on the real, 4i on the imaginary is right there. So this point is 3, and 4i is right there. So this point is 3 plus 4i. So, if that be the case, if we draw our perpendicular down and we draw the hypotenuse on this right triangle, notice that this distance is 3 and this distance is 4. When we're calculating the distance, we do not put the I in. So we're doing the Pythagorean, which is the distance squared is the a squared plus the b squared. The only difference in complex numbers, instead of x squared plus y squared, we got an a squared plus a b squared. Because you got an a plus bi, that's the x and that's the y, if you want to think of it that way. So we have d squared is 3 squared plus 4 squared. Notice you don't put the I in. 9 plus 16, d squared is 25. D is the square root of 25, so d is 5. Or we may use the formula, and the formula is what? Square root of a squared plus b squared with no I. Again, if you put an I in here, pretend, just pretend. If you put 4i in here and square it, you would get 16i squared. And that would be 16 times negative 1, which would give you negative 16, and that's wrong. So when you're doing the complex numbers and you're dealing with distance, the absolute value, you do not put an I in the place of the b. You use this formula. So a is 3, b is 4. Notice b is 4. You do not put the I in. It's a square. That's 9 plus 16, square root of 25, which is 5. So the same as the dealing with the x, y axes, but now when you're dealing with the complex numbers, we do not put the I in. So in this one, absolute value is the distance. So a is 6 and b is negative 8. So the distance is the absolute value. It's the square root of 6 squared plus negative 8 squared. Notice the formula is, and I write it down again, d equals the square root of a squared plus b squared. And that's the formula that's here. So I get 36. Negative 8 squared is 64. That's 100. And that gives me 10. So this absolute value of this point is the distance from the origin is 10. And the same here. We have a is negative 5. B is negative 12. So the distance is the square root of a squared plus b squared with no I. And a is negative 5. B is negative 12. And negative 5 squared is 25. Negative 12 squared is 144. And you add it up, you get a 169. And the square root of 169 is 13. Again, repeat. The absolute value is the distance from 0 on a number line, or from the origin 0, 0 on a graph. And in imaginary numbers, it's a squared plus b squared, square root. So find each. And I'm going to say using this. So this is the absolute value system of a negative 4. And if I use this, well, what we have, this is the absolute value of 0 minus 4i, 0. That means a is 0 and b is negative 4. So it's a squared plus b squared. A is 0. B is negative 4. And that's 0 plus 16, which is 16, which is 4. Now I use that formula only to show you this is a 0 and working it through. But really, how far is this on the axis? This is 4 units down on the imaginary axis, but it's the distance got to be positive. So the minus 4 is positive. You don't use the I. Note, you don't use the I. And again, we have A is negative 3, B is 4. So the absolute value is the distance. So it's A squared plus B squared. So A is negative 3, B is 4. That's a 9 plus 16, which is a 25, which gives me a 5. And again, remember, you're working out similar to plotting a point and setting up a right triangle using Pythagoras. And in C, A is 8, B is negative 6. So the absolute value of 8 minus 6i is really the distance. And the distance is a squared plus b squared. A is 8. B is negative 6. So negative 8 squared is 64. Sorry, 8 squared is 64 again. Just a few little mistakes I got to catch myself. And a negative 6 squared, negative 6 times negative 6 is 36. And that gives me 100. When you add, it gives me a 10. And another one to do, D, the absolute value of a negative 2 minus 4i. And again, just to remind you, absolute value the symbol for absolute value is the 2 strokes. And the absolute value means distance from the origin, 0, 0. So to do that, we say A is negative 2, B is negative 4, and we don't use the I. The distance is square root of A squared plus B squared. The distance, we do not use the I. And A is negative 2 squared, B is negative 4 squared, and that gives us negative 2 squared is negative 2 times negative 2 is 4. Negative 4 squared is negative 4 times negative 4 is 16. And that gives us the square root of 20. And the square root of 20 is 4 times 5. So it's a 2 root 5 as an exact value with no decimal. And just to remind you, just a little, negative 2 is the real. Negative 2 is right here. And negative 4 is right there because that's the imaginary. So this point, there it is right there. So that point is negative 2 minus 4i. That's that point. And this distance is the length of the segment from 0, 0 to this point. And we work it out quickly by using square root of a squared plus b squared with no I. And remind you, if I drew a perpendicular to the x-axis, this would be, oh, that's a negative 2 now, so I better be careful. This is a negative 2, so that's negative 2. I put a negative 3 there, so again, those errors. This is a negative 2, and this is a negative 4. So that's what goes in this equation. Sorry about that. I plotted 3 dots, 3 spaces. There should only be 2 spaces. That's negative 1, negative 2. And that's negative I, negative 2i, negative 3i, and negative 4i. Because this is imaginary. This is reals. So that brings us to the end of the video on finding the absolute value of a complex number, and that the formula is absolute value is distance square root of a squared plus b squared, but don't put the I in. If you like my video, click the like button, click the subscribe button, the notification bell to more videos coming your way, and visit my math website www.mathfullyexplained.com to find more information about me, my videos, and the content, and that's the content that's on my YouTube channel called Math Fully Explained. Thank you for viewing my video.